Now I have a helper here. Her name is Caroline. Are you ready, Caroline?
Yes.
Alright, so what you're going to do is put each of the chemicals in that we've chosen to test into one of our glasses. Alright?
Alright.
The first one we're going to do is vinegar. So Caroline's going to pick up the vinegar and she's going to pour it into the glass. And the color got considerably lighter. What color would you say that is now, Caroline?
Red.
The next one we're going to do is baking soda. What color would you say that is?
A turquoise.
The next thing we're going to test is called muriatic acid. Muriatic acid is the industrial name for another chemical called hydrochloric acid. It's a very strong acid, the same one that's used in your stomach to break up food. What color do you think that is?
Red.
Now we're going to add ammonia. What color would you say that is?
Green.
This chemical is called sodium carbonate, or soda ash. It's used a lot of times to raise the pH in swimming pools. What color would you say that is?
It is green.
Now we're going to try something that you're all familiar with, Sprite. What color did the Sprite make?
Wine color.
So acids turned it red, and bases turned it green, and the Sprite's a wine color. So do you think that means it's in the middle?
Yes.
So what does that mean you can do with Sprite?
Drink it.
The pH scale is a measure of acidity and basicity. Acids and bases are opposites. The pH scale goes from about 0 to 14. 0 is a very strong concentrated acid, and 14 is a very strong concentrated base. Most of the things that we've had an opportunity to work with today have been somewhere in the middle. Neutral is pH 7. That would be pure water. It's important to have the right pH in the swimming pool, which is why products like these are used to either lower or raise the pH and bring it close to neutral, which is approximately the right value. In reality, swimming pools are usually kept a little bit more basic than neutral. People who own swimming pools use acid-base indicators just like the one we use today. The indicators that they normally use are a little bit different, but the principle is the same. If you have a swimming pool, you have to make sure it's not too acidic or too basic. Keep in mind that acids and bases are opposites, and you add one to counteract the other. Starting from the most acidic, we have the hydrochloric or muriatic acid. What's its color?
Dark red.
And then we move on to the acetic acid or vinegar.
Red.
Then the Sprite.
Wine color.
Then the baking soda.
Blue-green.
Then the ammonia.
Green.
And finally, the sodium carbonate, which now has actually changed in color and looks more
Gold.
Here we can see the full range of colors. It's easier to see with light from behind. We start out with the most acidic solution here, which was muriatic acid. We move on to vinegar, and then to Sprite. Finally we get to baking soda, and then to ammonia, and last to sodium carbonate, the most basic. lowest pH, highest pH. You are watching a crude version of a process called titrating, in which acid is being added dropwise at the top to slowly neutralize the base. The original mixture is basic or alkaline, formed from sodium carbonate. Except for a short period, the audio portion has been removed. You can see the foaming from the carbon dioxide. Stirring helps not only to mix the reaction fully, but to drive off the carbon dioxide. At this point, the reaction mixture is nearly neutral, which is why the color is characteristic of the original color of the red cabbage indicator. Addition of further acid will be necessary to fully neutralize all of the base. A few drops more, and the acid color, the red color, will return. At this point, the red color of the acidic form of the indicator is now visible, and the titration is very nearly complete. The last remnants of carbon dioxide are being driven off. No additional bubbles are forming from the addition of more acid. Therefore, the titration is over, the neutralization is complete, and the indicator will not change further.